Good morning again. It is Thursday, March 19th, and your notes today are on modeling exponential equations. And if you remember from our last unit, modeling is just a fancy word for word problems, basically. So before we jump into some examples, let's get some vocab out of the way. The first word that we need to make sure we understand the meaning of is the word appreciate. The word appreciate means something increases in value. Examples of things that appreciate include a home. They could include antiques. If you've ever seen that show, Antiques Roadshow, we know that really old, really unique stuff appreciates in values, goes up in value. Some jewelry appreciates, if it's really nice jewelry. And when something appreciates, it goes up in value, you have to remember that you are retaining 100% of that original value plus the amount that it appreciates by. So for example, if your home appreciates by 2% per year, you are maintaining 100% of the value of that home plus the amount that it's appreciating by for a total of 102%. And for the purposes of exponential functions, we know that our growth rate, our b, is always written as a decimal. So if something's 102%, imagine that decimal point is on the far right-hand side. And to convert percentages to decimals, you move that decimal place 2 places to the left. In other words, our b in this case would be 1 whole to represent the initial value of that home, 100% of the value of that home, plus the additional 0.02 that it's appreciating by. Okay, so something to keep in mind here. Remember that you're including 1 to depict 1 whole amount of that original house, plus 0.02 to represent the amount that it's increasing by. Next word that we need to make sure we have an understanding of is the word depreciate. And to depreciate means that something is decreasing in value. So things that depreciate could be cars. Cars actually lose value the second you drive them off the lot. Other things that depreciate, boats. Boats lose value very quickly. Electronics. So for example, that first generation iPhone is probably worthless, but the brand new iPhone is really expensive. So there's some kind of life experience that's required for some of these problems. If you're ever not sure if an object appreciates or depreciates in value, just let me know. Or you could Google it or ask your mom or dad. Okay, so if something depreciates, we have to understand how to do the math for that. Let's say, for example, you buy a car, it's brand new, it's worth 100% of its original value. If we say that a car depreciates 20% per year, then you're actually taking 100% of that car minus the 20% that it's depreciating, meaning that car is still retaining 80% of its value. So you have to ask yourself, how much does the car retain in its value? How much does it keep? And to convert 80% into a decimal for our b, for our decay factor, we're going to move that decimal point 2 places to the left. So my b in this case would be 0.8. So if you think back to our b, if something's growth or decay, we know that if it's bigger than 1, it depicts growth, and if it's less than 1 and between 0 and 1, it depicts decay. So remember, the car is not decaying at 0.2. No, it's losing 20% of its value, but still retaining 80% of its value. Okay, so let's do some examples here. You purchase a car for $10,000 and it depreciates, loses value, at a rate of 15% per year. We're going to write the exponential function to depict the value of the car after X years. After X years. Okay. So first thing we have to pick out is the initial value, our A. And our initial value in this case is $10,000. The car was worth $10,000 when you bought it. So our function is going to be y equals 10,000 times b to the x power. And when we're figuring out this b, it is not 15%. It is 15% is telling you how much of the car's value you're losing. You need to figure out how much of the car's value you're still retaining, how much you're keeping. So we're going to subtract 15% from 100% to get 85%. In other words, even though the car's losing 15% of its value, it's still retaining 85% of its value year after year. And to convert this percent to a decimal, I'm going to slide my decimal point over 2 places, making my b, my decay factor, 0.85. So if I want to know how much is my car worth, after 5 years, I can use this function and plug in x for the number of years 5. So my car will be worth, after 5 years, oops, I can plug this into my calculator, $10,000, keeping 85% of its value year after year, raised to the 5th power. My car is only worth $4,437. $5. So after 5 years, your $10,000 car is worth less than $5,000. And unfortunately, that's kind of accurate. Cars lose value really quickly. Okay, let's do another example. Okay, I am pulling this example from your homework packet. The very, very last page of your packet where it says equations from context, I'm going to do number 5 from that packet. It says, a Gila monster is about 16 centimeters long at birth. During the beginning of its life, the Gila monster length increases by about 15% each week. We're going to write the exponential equation to depict the size of the Gila monster after X number of weeks. So first thing we know is our initial value. It says that it's 16 centimeters at birth. It then says it grows at a rate of 15% each week. But if I put 15% here, 0.15, remember, this is less than 1. That's depicting decay. So we have to remember that to depict growth, we're keeping 100% of that Gila monster's value plus the additional 15% that it's growing by. So 100% of the Gila monster plus the 15% that it's growing is going to be 115%, or 1.15 as a decimal, raised to the x power, where x is weeks. Okay, so there's my exponential function. Next, it wants us to find the length of the Gila monster at the end of 3 weeks. So we're going to use our exponential function and plug in x for 3. Use my calculator here. 16 times 1.15 to the 3rd power is 24.334 centimeters. Final answer. Okay, guys, that's it for notes. Your homework is to finish those 3 pages in your packet. They start with exponential functions context notes. You've got 3 word problems on that page. You've got 1, 2, 3 on the next page. I did the Gila monster problem for you. You're going to finish 6 and 7 on that last page. The answer key is up online, and as always, please let me know if you have any questions. Good luck.